Hey guys, welcome back to another video about machine learning models. So today I'm gonna work with breast cancer dataset. So where the machine has to classify breast cancer detection, whether the patient how likely to get the breast cancer. So we have a sample data set which is an inbuilt data set from sklearn. So we are gonna prepare the model by doing training and testing the data set. Then the machine will detect based on the tumor cells, cell size, or some categories are there in the data set. So if it is all matches, and the patient will likely to get diagnosed with the cancer. So that is how we can use this machine learning applications in healthcare sector. So when we had the basics of machine learning, so I spoke about the applications. So this is a use case where the machine learning is using, like the in healthcare sector. So machine learning can be used to detect the breast cancer. So it is very important to detect and prevent it. So today we are gonna cover this classification problem with a random forest. So since I have covered linear regression and also logistic regression and also decision tree, so today I'm gonna work with a random forest machine learning algorithm. Since this is a multi-class classification problem, I can also use a decision tree, but I never used random forest. So that is the reason why I wanted to use random forest classifier algorithm. At the end, I wanted to compare all the machine learning like classification problem machine learning models. Like I'm gonna use logistic regression as well as decision trees and as well as the random forest. So we are gonna see which model is trained well. So we are which model has the high accuracy rate and high precision rate. So we are gonna test all these things. So let me briefly explain about how the random forest, what is the random forest. So basically, random forest is a assembled learning method used for classification as well as regression and other tasks also. So today we are going to work on a classification problem, and so but it can be also used for regression problems, like a where my target variable is a continuous variable, nothing but predicting house prices, car prices, or stock prices, where the numbers involved, not the categories. So that is nothing but a continuous variable. So those problems are called regression problems, where the relationship between the input variable and output variables or something like that, a regression problem, a regression line will come into the picture, y is equal to mx plus c. So those kind of problems also can be solved by random forest. It operates by constructing a multitude of decision trees during training time and outputting the mode for classification or mean prediction for regression for individual trees. So here in the above image you can see, so it is combination of decision trees. So here you can see one decision tree, second decision tree 3, decision tree. So it could be n number of decision trees, and the results will be combined. So it will collect the majority voting, then the average will be predicted by the random forest model. The key idea is to combine the predictions of multiple decision trees to improve the overall performance and the robustness. So that is what it is, a combination of decision trees. The random forest is nothing but the combination of multiple decision trees, so that we can combine all the predictions of multiple decision trees. So we can get one prediction here in one decision tree, and also another prediction. It could be like nth prediction, 1, 2, 3, so on for nth prediction. It all the predictions will be combined, and we will take the average value of the all the predictions. So that is how the random forest algorithm will work. So today we are gonna work with a data set which is an inbuilt data set from sklearn, so which is breast cancer detection. So let me import all the necessary libraries for today's session. So I'm importing pandas as PD for data manipulation, importing NumPy as NP for mathematical computations, import matplotlib dot pyplot as PLT for visualization. I don't want to see any warnings, so I'm importing warnings dot filter warnings. Let me ignore it. And then I just wanted advanced visualization, so I need to import Seaborn. Import Seaborn as SNS. So let me run this. So I have imported all the basic necessary libraries. So let me import all the other libraries from scikit-learn for the to train the model. So from sklearn dot dataset. So first let me import my dataset, which is breast cancer. So this is one of the dataset in sklearn. So you can use it for practice purpose. And also if I wanted to import the model sklearn dot resemble. So this is how we need to import the model. Today we are gonna work with random forest. So random forest classifier I wanted because I'm working on a classification problem. And if I wanted to evaluate my model sklearn dot metrics, I need to import confusion matrix. So today I also plan to explain what is a confusion matrix, how it is important when we are working on a classification problem. So also I just wanted to explain how, I mean, why we are using this confusion matrix to evaluate the model, and also classification report. So we just loaded data set, and also I imported random forest. So let me import train test split dot model selection, train test split, to split my entire data set into training and testing part. Okay, so let me run the cells. Okay, now I'm able to run the data. So I'm just assigning variable df is equal load breast cancer. So I'm just importing the data has been imported. Now I need to read the data. So if I wanted to look at the keys, so print df dot keys, then it will give me, oh sorry, it will give me all the keys which are related to the my data set. So let me see the description about the data set first, so that we'll be able to understand what exactly the data set is about. So here you can see the breast cancer data set from description. From breast cancer diagnostic data set, features are computed from a digitalized image of a fine needle of using the decision tree construction via linear program prediction. So relevant features selected using an exhaustive search in the space. So you can, so this is how you can get the description about the data set. So this is about a brief description about the data set. So let me assign my X and Y. So my input features, and so my data is df dot data. Since data is stored in data, df dot data and my columns are uh, feature names. Data dot feature names. So this is my, oh sorry, I have assigned it to df. I need to specify df dot feature names. Okay, now if I wanted to look at the dataset x dot head, then it will give me top 5 rows. So here you can see mean radius, mean texture, mean perimeter. I think it is the size of the tumor or size of the cell, where if it is as per the cell, like a cancer cell, if it is matches, or if it is matches with the cancer cell, then I think it will predict, okay, this person is likely to get breast cancer. That is how it will, the model will predict. So these are all the features. Mean area, mean smoothness, mean compactness. So you can, so we'll be having a lot of input features. So based on all these input features, so we do have a target variable. Let me load target variable also, df dot. My target variable is df dot target. So if I wanted to look at the y, so see, it is zeros and ones. So zero nothing but I mean there is no, I mean the person is healthy, there is no detection, I mean there is no cancer or something like this is found, is not found within the body. One being, it is positive result, like the particular column or particular details are reflecting to a cancer cell. That means a person is likely to gonna get diagnosed with the breast cancer. So that is how the model will behave. So these are all my input features, and this is my target variable. So these are all zeros and ones, nothing but. So zero is being no, and one is being yes. So that is how the machine will predict. Okay, so here you can see in that image also. So this is a basic image how the model will work. And so I have done with my input feature engineering, like I have segregated my data into features and target variable. Let me split the data into training and testing. So let me use xtrain, xtest, ytrain, ytest. So this is my xtrain, xtest. So the syntax is train, test, split, xtrain, xtest, ytrain, ytest, and test size, and also the random for the random state. So I'm gonna run this cell. So I am dividing my entire data set. So here let me look at the shape of my input features as well as my output target variable y dot shape. It will give me. So I have 569 entries and 30 input features. So we have that 569 values entered. So we are gonna look at 569 members details, and the my entire data has, and obviously output is also one of the column. So we have 569 output features, sorry, output values or target values. So I'm gonna split this 569 values into a training data set and a testing data set. I wanted a 33 percentage of the data to be tested. That means I want 66 percentage of the data. I'm using 66 percentage of the data for training purpose. So I will train the data on 66 percentage of the data, and then I'm gonna test the model on 33 percentage of the data. So random state I'm giving 42. Let me run this and let me look at my xtrain metrics. So it has to give me 66 percentage of the data. So out of 569, we have 381, which is correctly done. Like 381 entries are trained. So I mean, we split the data into training testing. So let me also look at my testing data. It has to be 33%. So 188, which is nothing but 33 percentage of 569. So that is how we need to split the data into training data set and testing data set. So we are done with it. Let me import the model here. I wanted to use a random forest classifier since it is a classification problem. So I'm gonna use a random forest. So my model is done. I imported the model, and let me train my model dot fit. I need to pass the testing data sets, xtrain and ytrain. Okay, so model has been trained. Now I need to predict the values. Model dot predict, and I need to pass this x test values so that the model will predict, and then we can compare the actual values than the predicted values. So if I look at the y pred, so this is how the machine has predicted. So also if I wanted to look at the actual values, y test, then let me compare y test and y predict. So here you can see 1 1 0 0 1 1 1 1. So almost machine is predicting very similar to the actual data, but here you can see here 0 is there, here it is 1. So accuracy is not 100%. So that is how we need to evaluate the model by using confusion matrix as well as the classification report. So let me, so this is about a confusion matrix. So actually the confusion matrix to evaluate the classification problems. So here you can see the actual values 1 and 0 and 1 and 0. So we have like true positive and false positive, false negative, true negative. So here you can see, so for example, if I compare my actual values 1 and 0 and predicted values, so my actual value is 1 and machine also predicted 1. That means true positive, both are matching. So here you can see a woman with a image with a pregnant. So this is true positive, machine predicted correctly, and my actual data set is also saying that okay, with these values, okay, this woman is pregnant. And here you can see the actual value is 0, actual value is 0, false positive, and my machine has predicted as 1. 1 is nothing but a pregnant. My machine originally I just feeded the data for a guy, and machine is to test whether the man that guy is a pregnant or not. By my machine predicted as okay, the person is pregnant. That is obviously false, right? So that is why that is false positive. My actual value is 0, but somehow my machine model predicted as a pregnant. So that is how you can evaluate the classification problems. And next, so my actual value is 1. Like originally in my data set, with the all the input features and output feature is telling me that the person is a pregnant. But after training the model, machine is predicting as 0. That nothing but false negative, which is giving me a false prediction and a negative, not a pregnant. The true value is like actually the person is a pregnant, but machine is predicting like not a pregnant. So that is about false negative and true negative. True negative means originally my original data set is for like this person is not a pregnant, and my model is also predicting correctly. So these two value, true positive and true negative, we can like machine is predicting the accuracy is 100% on true positive and true negative, whereas the false positive, false negative, so machine is predicting incorrectly. We have input like I have in my data set, I have a different values and machine behaving or machine predicting different values in false negative. So this is how the confusion matrix will work. True positive, false negative, false negative, true negative. So basically true means nothing but the machine is predicting correctly. True statement. Actual values are equally predicting to the predicted values. Actual values are equal to the predicted values. So that is why true. So true. Positive means okay, positive result. Okay, the person is a pregnant. Okay, my actual values and predicted values are same. And negative means the person is not a pregnant. The my actual data says that the person is not pregnant, and also my machine is also predicting the same results which we have it in the data set. So that is how you can evaluate the classification model by using this confusion matrix. So so here you can see true negative, the number of instances where the model correctly predicted the negative class, and the false positive, this is false positive, the number of instances where the model incorrectly predicted the positive class, type 1 error, this is nothing but a type 1 error. And false negative, this is the number of instances where the model incorrectly predicted the negative class, this is a type 2 error, this is type 1 error, type 2 error. Where the my original data set is saying that this is like the person is not a pregnant, but my machine is saying that person is a pregnant. That is why it is a false positive, predicting false and giving me positive results, false positive. So that is where the type 1 error will come. And type 2 is nothing but the number of instances where the model incorrectly predicted the negative class. So the machine is predicting incorrectly with a negative, like the person is not a pregnant, though the person is a pregnant, but my machine model is predicting as a not a pregnant. And the true positive, the number of instances where the model correctly predicting the positive values. So this is how the confusion matrix will work. So let me uh, look at confusion matrix is equal to, so let me take my confusion matrix from the matrix confusion matrix, and also I need to look at the classification report also, how the machine is behaving. And let me pass my y test comma y pred, means y predictions, here also same. So I wanted to look at the confusion matrix as well as classification report, how the model is trained. So what is the accuracy, what is the precision. So let me run this confusion matrix classification report, and I'm printing this, I'm printing this. Okay, so here you can see a confusion matrix of 63. 63 nothing but a true positive statements out of uh, how many points we have, 300 and total 569 points we have. So out of 569, no, that we have split it 381. So out of 381 points, so machine is saying that 63 true positive points, and machine is predicted correctly positively on 63 instances, and this 4 being a false positive. and this is for false negative and true negative. 117 results are false negative, sorry, true negative. So this is how the classification matrix works, and the classification report says that the accuracy of the model is 96%. That means model is trained well and it is giving me good results. So this is how you can evaluate the model. So let me also look at the other machine learning models, and also we can compare uh, which model is predicting exact values and which model has high accuracy rate as well as high precision rate among, because this is a classification problem statement. I can also use logistic regression, I can also use decision trees, I can also use, I already used random forest. I just wanted to compare these three classification problem algorithms now. Just then we will look at the precision out of three. So if I wanted to use the other classification algorithms, which is logistic regression, so I just imported logistic regression as well as decision tree classifier to just to check the which model is trained well. So I'm gonna follow the same steps here. So here I just use logistic, assigned it to logistic model because I'm using logistic regression, and this is my maximum iter is equal to, I'm giving 10,000 and random state I'm giving 42. So my model, I'm just using this X train, Y train from the above, and my this is the predicted values. So if I wanted to see the classification report confusion matrix on the same way, similarly here we just we just looked at the random forest values, how the classification report. So we have around 97 percentage of precision, and accuracy is 96% accuracy. So let me also look at the logistic regression precision and accuracy. So my logistic regression give me 97 percentage of precision, sorry, 98%, and accuracy giving 96%. So I'm getting more precision with the logistic regression, and accuracy is similar to the random forest. So if I wanted to apply the same thing by using, so here you can see the confusion matrix. So 65 instances with the true positive. So this is how the confusion matrix with the logistic regression. And also if I wanted to look at the decision tree classifier with the same data set, and it is giving me 95 percentage precision, and my accuracy is 92%. So among all these three classification algorithms, I am getting good results. I can say random forest is giving me good results only. So compared to logistic regression and the decision tree classifier, I am getting a good, model. The model has trained well by using random forest only. So that is how you can look at, or you can compare the different classification algorithms, machine learning algorithms, to just to see which model giving me high accuracy rate and also high precision rate. So that's it for random forest algorithm. So I hope it is like clear, like I have explained everything by using this sample image, how the random forest is working with the multiple decisions, how it is aggregating by using all the, this is internally when we, when we import the model and when we do the training part, then the internal system will do these computations, decision tree 1 2 3 4, and based on the first prediction, second prediction, third prediction, the machine will predict the final results based on all the combined decision tree predictions. So and also, so we used cancer, breast cancer detection data set. So the data set looks like this. So we have the predictions 1 and 0, and we also imported the data from sklearn, and I split the data into training and testing data set, and I used 33% of the data for testing purpose, and also imported the random forest classifier, and the my model is predicted, these are my predicted values and these are my actual values. And if I evaluate the model, my confusion matrix says that the precision is 97% and accuracy is 96%. That means machine is predicting 96 percentage accurately. There is a margin of error for 4%. Similarly, I just used other classification algorithms, logistic regression and decision tree classifier on the same data set. Those, I mean, I'm getting 97 percentage, sorry, 98% precision, 96% accuracy is 97% on a logistic regression. And if I use the same data set and if I train the model by using decision tree classifier, and it is saying that accuracy of 92% and precision is 87% for zeros and 95% for ones. So that is how we can apply different kinds of classification algorithms. So I hope it is very clear, because I compared everything and also explained about confusion matrix. So if you really like the video, please don't forget to subscribe the channel, and also if you enjoyed this entire video, then please like the video so that it can recommend to the others who wanted this, like classification problems or anything related to the data science. Then the content will be or shared with the others, if you are liking the video, so that it can recommend it to the others as well. So if you like it, then please click on the like button. So thanks everyone. Bye.